Assalamualaikum and hello. My name is Fauzi bin Raihan and I will be explaining about my final year project based on the poster that I have done. The title of my poster is Linear Voltage Regulator Modeling using System Identification for Failure Analysis Application. From this poster, I will be explaining about the problem statement, objective, system identification and what it is, my flowchart, methods and results, and last of all, conclusion. VR manufacturers, VR means voltage regulator manufacturers, estimate the failure region boundaries to time-consuming manual process that requires highly skilled expertise and engineers. It is difficult for manufacturers to know the exact internal parameter values of manufactured VRs. Aging and temperature change of components can also be a factor of changing stable regions of linear voltage regulators. Therefore, there is a need to estimate the VR model to make the process more efficient, yet effective and accurate. So, my objectives for my final project is to estimate the VR model accurately using system identification or SI technique, to analyze the failure region based on the SI estimated model, and to evaluate the efficiency and effectiveness of failure region estimation based on model-based approach. System identification. System identification is a method for estimating and validating models from output and input data acquired from the actual system to find the model that best describes the system. This SI method helps to find the linear voltage regulator system model without manually testing each and every point of the ESR tunnel graph. So my flowchart for my project is to take data from PSpice to MATLAB, then use the system identification to get the transfer function of system of each point, then use neural network to train AI for some data points, get AI generated transfer function of system, then test transfer function for unknown data points, and verify accuracy and usability of transfer function. We can also verify the accuracy by comparing the transfer function from the AI generated neural network to the system identification of to the transfer function of the system identification. And then finally, use AI generated transfer function to test pass fail of LVR based on input. Methods and results. Before using system identification, pass-fail test is done manually for a data point with corresponding equivalent series resistance, or ESR, and load current value. Pass-fail is measured based on the number of oscillations of output voltage when undergoing a transient load test. A data point is plotted into a graph called ESR tunnel graph, and the test is repeated with various values of ESR and load current until the graph is complete. Data is then transferred to MATLAB to undergo system identification and neural network. System identification estimates the system model, transfer function, coefficient of a given waveform based on the structure and the number of coefficients the user wants. The transfer function estimated is compared with the actual waveform by using best fit percentage to determine the best structure or number of coefficients to use. The model fitness is right behind my camera, so I'm sorry that I blocked it. The model values are then used in MATLAB's neural network. Hundreds of data is viewed by artificial intelligence and is trained repeatedly to have the same system model as the transfer function model from system identification. Regression plots is obtained for validity of system model generated. After verifying the accuracy of the system model, the output impedance, or ZOut, model transfer function is then used for the failed test pass-fail tests of unknown points that have not been analyzed from manual testing. Conclusion In conclusion, this project successfully achieved the objective in modeling the linear voltage regulator circuit using system identification for failure analysis of the system. In addition, this study is also successful in improving the accuracy and efficiency of failure region estimation based on model-based approach. Thank you.